Okay, so I wanted to kind of go over a few things. I just went through the pseudocode discussion and chapter 2 homework, and I just kind of wanted to clarify something. So I know there were some comments on students being kind of confused on how to write pseudocode. I really feel like some of the students were kind of overthinking everything. I'm not sure where they got their instructions on, but they were saying things like, well, they searched different textbooks or they went on YouTube. There, I had like one page about pseudocode. If you went to the chapter 2 module, and toward the end of the chapter 2 module, I gave this description of pseudocode. I described a problem and how to approach it. I just wanted to kind of clarify things. So this is not actual code. I know some people turned in actual code, and that was actually the wrong thing to do. So what you're supposed to do is just simply just make instructions to yourself that aren't that aren't like syntax based. So you don't want to get into technicalities of syntax, because you're actually making statements and instructions that can be used in any programming language. Now I know in my instructions I kind of gave like a generic example of how to broaden what you say or how to be more specific about the syntax. Either case, it's fine. But the approach that I was wanting to see is what steps you actually take to solve the problem. So you take in $47.63. Okay. Now you can at the beginning you can like write all the things you're going to declare. But one of the first things you're going to do is prompt the user for his amount. They enter $47.63, and then the next step that you would do would be figure out how many tens are in $47.63. So I did go through everybody's group discussion, and I saw there was a lot of good answers out there. First thing you actually do, the thing that we do in our head immediately, is we take $47.63 and we divide it by 10. And we say, okay, well, how many times does 10 go into $47.63 evenly? And the answer is 4. So you take 4 times 10, you get 40. And then you subtract 40 from $47.63, and you're left with $7.63. Then you got to ask yourself, how many times does 5 go into $7.63? And your answer to that is 1. Okay, so you have $7.63. 1 5 goes into that. So you're basically dividing that amount by 5, and then you're subtracting that 5, and then you're left with $2.63. Okay, and you could go and so on and so on and so on. Like that is kind of the approach that you would have to take as far as what statements you want to write down in your pseudocode. I know it kind of stinks, I guess, for online students, because a lot of times they're afraid to like just comment or write what they're thinking. But you kind of have to just break out of that mind frame. Like just type out whatever you think it is, whether it's wrong or right, and your peers will kind of discuss what they feel and type. They would give their input, and you guys can kind of collaborate and come to some type of agreement on what the proper solution is. So you kind of have to break out of that mind frame of not wanting to participate. I know on the online class, there's a lot of students who do everything last minute, which is really disappointing. Not for myself, but for you. I kind of feel like if you're waiting to the last minute to do your work, you're putting everything off to the last minute, you're not going to pass this class. I'm sorry to say that. I could already tell who's going to pass, who isn't. And chapter 4 is going to be very difficult. And if you're not already in the mind frame of reading and asking questions and doing things early, then you're going to struggle in chapter 4, and you're going to end up failing this class. So please do your best to break out of that. I know there are students who haven't turned in work. I've been trying to reach out to them, and they don't reply, or I guess they're not actually seeing the messages that I'm sending them. But for an online class, I mean, it's like a lot of the onus goes on the student for actually motivating themselves to do the work. Okay. So the next thing I want to talk about is the homework. So I did grade chapter 2 homework, and there's a lot of common mistakes. People aren't following the coding standards. So I'm kind of just going to go over this really quick. If you go to the assignments, and then you go to just one of the homework assignments. I just graded chapter 2, so I'm going to click on chapter 2. Now, I give you very specific instructions here, and I kind of feel like students are just not reading it or just jumping straight to the book problem and just following the instructions on the book. So my instructions on the description of the homework here supersede what is actually the instructions on the book. So if you kind of read through this, I tell you to follow the coding standard. A lot of people are not actually doing that, so I want to kind of just point out some things that people are violating. So the first thing that people are violating is class names and file names. They need to be something meaningful, not programming problem 2 point whatever or quiz whatever. Like, they need to have some meaning. So for instance, the temperature converter in chapter 2 should have been named something like Fahrenheit to Celsius temperature converter, or just temperature converter, something like that, not programming problem 2.5 or 2_5. The other thing is class names and file names have to begin with a capital letter. Now, some students, I don't know if they're doing this before they actually compile, but they're turning in their work and then they're changing the names of the files. And when the file name and the class name don't actually match up, meaning one has an uppercase, one has a lowercase, your file is not going to compile. Some of the other things that was a huge violation for chapter 2 is constants. I need everybody to read over constants because you're not actually using them correctly. So whenever you use a constant, you're going to have to give the name in all caps, but you also need to use the final modifier. And it doesn't say it here to use the final modifier, but that's actually something that we discussed in chapter 2. So to make something a true constant, you need to put final, the data type, and then you give it a name. The name that we're going to give it is a name in all caps. Now, we're going to avoid what we call magic numbers, meaning you should not have any literal values inside of your equation. So for the temperature converter, you had a minus 32 and then multiply by 5/9. Okay, so you should actually define constants for the 32 and the 5/9. And I'm going to go ahead and do an example of the temperature converter. And I believe, there's other coding standard violations is the proper indentation. I've made comments on that for some student, but I think most students are compliant with that. But there are a few who aren't actually following the correct indentation and spacing. And one of the other things, I don't think it's on here. Let's see. Okay, it is on here. So variable declaration. So all variable declarations should occur at the top of the method. Okay, so that's inside of the main method, but at the very top, you don't want to declare variables throughout the program. Now, this is just declaration, not necessarily assignment. So you can assign values to the variables later, but they all should be declared at the top of the method. Okay, so with that, I wanted to go ahead and do the temperature converter just to kind of show students like how this is actually supposed to be done. So I have the book here. I'm going to hop over to the programming problems. So programming problem 2.5 says to create a version of the temperature converter application from Fahrenheit to Celsius. Read Fahrenheit temperature from the user, and then you're going to convert it to Celsius, right? So in the book, I don't know if you guys actually read the book, but if you look in, I think, section 2.4, let me see if I can find it. They give you an example of a temperature converter program that converts Celsius to Fahrenheit. And here it is. Okay, so they pretty much wrote it for you, except this is going the opposite direction. So here they're declaring a constant they're declaring the Celsius temperature inside a variable, and then they're doing their conversion. Now, if you can see here, they actually use constants, which is something that I want you to use. They have the final modifier, they have the data type, and they have the name of the constant in all caps. Okay, so they did it here. The only thing that they didn't do that I'm requiring you to do is prompt the user for the data. So if you hop over to my instructions, if you read them all, I do tell you right here at the very bottom that I want you to use a scanner class, and I want you to prompt the user for all the data. Okay, so the proper way to write 2.5 is to actually prompt the user for the information. So I'm going to go ahead and do that really quick. And I am going to put this on Dropbox. I've already graded everybody's work. I know there's some people who didn't turn anything in, or they turned in the wrong files. It's too late for a grade. I apologize, but I have to get strict about my requirements. I think the instructions are pretty clear about what you need to turn in. Okay. Let's see. So just read these instructions. I tell you exactly what needs to be done. I need your Java files, and some students aren't turning that in, or just not turning anything in at all. Okay, so I'm going to go ahead and open up an example. Or excuse me, I'm going to do an example. I'm going to go ahead and open up Notepad++. So I am going to create a file. Let me see. So new. Already had a new file open. Okay, so I'm going to go save this. And I'm going to put this in chapter 2. So this is going to be in Dropbox. And I'm going to label this. I'm just going to label it temp converter. Okay. Label it temperature converter. And it's going to be a .java file. I'm going to save this. So up top, I'm going to have my name and my date and all my information up top. The next thing I want to do is I will know that I'm going to use the scanner class. So I'm going to go ahead and import the scanner class. So I'm going to say import java.util.scanner. And then I'm going to create the name of my class. So this is my class header. So public class, the name of my class, which matches the name of the file. Both are case sensitive. They both have to match exactly. Then I'm going to go ahead and write out my method header, public static void main string array. And then my arguments, open, close, curly braces. So inside of here, I'm going to have to do all my conversions. Okay, so I need to think about what type of variables I'm going to need. So the first thing I know I'm going to need is I'm going to need a scanner to do the reading of the input from the user. So scan is equal to new scanner that reads the keyboard. Okay, and then I'm going to go ahead and create some constants here. So I'm going to have a final, and let's see, final int base. My base is 32, and then final float, and I'm going to have, let's see, conversion. And conversion is going to equal to 5 divided by 9. Now 5 divided by 9 is an integer divided by an integer. So integers do not retain the fractional part. So 5 over 9 is actually less than 1. So the result of 5 divided by 9 is going to be 0. So if you do that, you're actually going to get the wrong result whenever you do your multiplication. So you need to make one of these a float. We can use float literals. This is something discussed in chapter 2. You can use float literals by putting a f on one of the numbers. We're forcing the 5 to a float. So that means we're going to divide 5 as a float by 9, and we're going to retain the fractional part of that division. The next thing I want is I want two variables. I want degrees in Fahrenheit and degrees in Celsius. So Fahrenheit is going to be what I'm going to prompt the user for. So the user is going to enter his degrees in Fahrenheit, and then I'm going to output the result in Celsius. So the first thing I'm going to do is I'm going to say system.out.println. Excuse me, just print, not print line. That way the prompt and the input happen on the same line. We're going to say enter your temp in Fahrenheit. And I don't know how to spell this. Dang it. I think it's Fahrenheit. All right. I don't know. That's close enough to me. Okay. So prompt the user, and then I'm going to say ftemp is equal to scan.nextFloat. That's going to read the next float that's entered into the keyboard. And once I have that degrees in Fahrenheit, I can go ahead and do my calculation. And the calculation for this is ctemp is equal to ftemp minus my base. And I believe I do this subtraction in parentheses, and then I multiply by my conversion factor. Now, if you're not sure, what you can do is just hop over to Google and just type in Fahrenheit to Celsius equation. And we'll just click this one. Dang it, what the heck. All right, maybe not that one. Just look. Okay, well, here it's telling you what to do here, but I was actually looking for the full equation. But here they're telling us deduct Fahrenheit by 32, then multiply by 5, then divide by 9. So the conversion factor is this, 5 over 9. So we're basically going to subtract the base and then multiply by the conversion factor. We get our degrees in Celsius, and then I can just say something like system out, print line, and I can just print back their temperature and Fahrenheit. I can say whatever you entered in Celsius is, and then give back the C temperature. Okay, so Celsius temperature is actually based off the freezing point and boiling point of water. So you can come up with some pretty easy test data. If you enter 212, then 212 was going to be 100 degrees Celsius. If you enter in 32, which is the freezing point of water, 32 degrees Fahrenheit is 0 degrees Celsius. So those are like 2 test points that we can test to verify that our equation is actually doing the correct thing. So I'm going to go ahead and save this, which I saved. I'm going to go ahead and open up command prompt, change directory to Dropbox. Dropbox, what's this Vista? Wait, public, that's right. Dropbox public, NVC, Java shared content, demos, chapter 2. Okay, then I'm going to go and compile, and the name of this is temp converter. It does compile. I'm going to run this temp converter, Java temp converter into degrees, into your temp in Fahrenheit, and I'm going to say 212, and 212 is 100 degrees Celsius. Now, there is that 0.00001. I know that's maybe like a little scary to some people. Now, what's happening here is whenever you do any type of math in a computer, what happens is it gets converted from decimal, meaning base 10, to binary, base 2, whenever it's actually processed. So the result can have these weird little fractions that are off. If you read there's some IEEE standard of how accurate these are supposed to be. You can look into that and read about it. Basically, this is acceptable for a computer, but if you were wanting to like completely get rid of all of that, there's some things that you can do. Let me see, what can you do? You can use, there's classes for like big decimal or things like that you can use, or you can like, you can round, or you can like format your value to just be to a specific place that you want, like the tens or the hundreds or the thousands. There's several things that you can do, but that's close enough to being the right answer. I'm going to go ahead and run this again, and I'm going to type in 32, and then my result is 0. Okay, so that seems correct. I'm going to go ahead and run this one more time. I'm going to enter in 75, and I get back 23.888. I can hop over here and verify against an actual calculator online by entering 75, and I can see the result right up here. Okay, so that is how you do the problems that you turned in. A lot of people actually did not create constants. That is something I'm going to look for. So make sure you actually read the coding standard, especially when it comes to future homework. Okay, so chapter 3 is the next homework that's due. There are some instances where you're going to have to use constants, so make sure you do that.